I missed your Zoom call last week, and I was really interested in your explanation of how the immunity system works, because there's so much to do about it in the media and everywhere.
Yeah.
It's all about how to boost your immunity system, and I'm like, okay, so but how does it work actually? Like,
it's a good question, because I think there's a lot of talk about, you know, what's going on, and I don't want to talk particularly specifically about coronavirus. It's more about, well, how does the body work? Because in reality, the body does the same thing regardless of what sort of invaders are coming in, bacteria, viruses, funguses, whatever it may be. We behave in a particular way, and our body is there to protect us. So I thought it would be a good idea to get back to basics and say, okay, what does the body actually do? Because I think a lot of people sort of think the immune system is sort of all on the inside, and actually it's a bit more than that. So that's sort of where I'm coming from with that. So
because I also hear a lot about, like, more on Instagram and social media. It also has a lot to do, they say, with stress and all those things.
Yeah.
Well, I wonder how it affects.
Yeah. And that's exactly it, because our immune system behaves differently during stress. So what I'll do here is I'll sort of be covering this sort of area. As you see on the screen, we have sort of like the little DNA strand, the cell, and then we have the interaction of sort of our detox process, getting rid of rubbish, which is mainly reliant on the liver and the lungs and the kidneys. Then we have what's called the gut-brain axis, how our brain communicates with our gut. And a lot of people have heard about this, you know, friendly bacteria. Yeah. And then we have quite literally our skeleton, which protects our organs. And then we have the body itself, the skin, what's on the skin. Yeah?
Yeah.
Move on to this. If we take the idea of a castle, yeah? Yeah. Is that the way in which a castle operates is very similar to the way the cell operates. Yeah, what you have is you have the castle walls, and then you have sort of like an inner castle, which is called the keep, which is sort of where the king and the queen sit and give out instructions. Yeah, and then all the workers are sort of within the wall, and then on the outside you have that big round moat where the water is.
Yeah,
and there is one way in. There's usually like a drawbridge. Ding, ding. Yeah. And that one way in, goods come in, products, whether it's food or weapons or whatever it is, and then someone takes away the waste. Yeah.
Yeah.
And this is, in principle, what goes on. Now, if when an invading army comes on, one of the options is to stop any supply of goods coming in. And it's called besieging. You know, they take siege against the castle. They just simply stop the ability of the castle to function with this goods coming in, waste going out. So what happens is disease builds up. They can't get rid of their waste. And so they'll end up giving up through either death or disease or starvation.
Yeah.
Okay?
Yeah.
So if we take that as an analogy for the cell, it's very similar. Is that what you have is, if you think about the largest example of a cell we have is, say, an egg. Yeah, you've got sort of the yolk in the middle, and then we've got the white on the outside.
Okay. Yeah.
Very similar to a castle. And in terms of goods coming in and out, what we have is we have oxygen comes in, and the waste is carbon dioxide. You know, breathe in. Yeah. And also from a nutritional point of view, and I'm oversimplifying this, it's a much more complicated process. In essence, this is a fairly good analogy, is that magnesium comes in and calcium is sort of the waste product that comes out of the cell. Yeah. And this creates a switch. It's actually a type of electromagnetic switch, and it acts a bit like a battery. Is that the magnesium-calcium balance coupled with the hydration in the cell, the water in the cell, creates like a battery effect. And quite literally it creates an electromagnetic shield. So when the cell is healthy, what you actually have is we are becoming impregnable. That shield is a bit like the moat. It's that first port of call where it's the first line of defense. And we generate a magnetic field, and we are made up of about 50 trillion cells.
I was just going to ask that. Like, we have...
Yeah, I mean, I don't know who's counting, to be honest. You know, I've got this image of some guy, counting cells 1, 2, 3, and so it's somewhere between 37 and 50 trillion cells, which seems like an awful difference, but yeah, it's a lot anyway. And each one of those has a magnetic field.
They all have it, like every single
cell. So we generate a magnetic field. Yeah. When we're healthy, quite literally, we're impregnable. Nothing can get in. The thing is, just like the castle, if there is a supply problem, then there's a problem, because magnesium, if there's no magnesium, which is what happens when we get stressed, our magnesium levels drop. Suddenly, our ability to take in oxygen, we're not at optimum, because magnesium is key to oxygen uptake. And also, we can't get rid of calcium as easily. So that what happens is we become literally tense, because that's the job of the difference between magnesium and calcium is magnesium relaxes muscle tissue and calcium tightens muscle tissue. That's why when we get stressed, we're tight. Yeah? Make sense so far?
Yeah, I think it's really interesting to actually see scientifically that it's also a fact that stress infects, like why it's so important to de-stress. And like, I'm trying to meditate, to yoga, to ease my mind, and sometimes I wonder, like, does it really help? But if I see this now, I also understand that it helps for my general health, actually. So
before I go any further, it's sort of worth talking about the stress bit, is that it's not made up. The stress is literally what's called our fight or flight mechanism. And it is part of the immune system. If anything, it is that first part of the immune system. It's because what actually is going on is that, just like the lookout at the castle, he's sort of looking out and sees the invading army and sort of says, oh, friend or foe? Are you the good guys or the bad guys?
Yeah.
And we make a decision, and based on our decision, then we create an action. Yeah.
So that is what we do all the time.
And so therefore, if we feel
into our head and everything that,
So if we feel threatened based on a whole series of factors, have we experienced that enemy before, or have we experienced that friend before? Were they easy or stronger than us? Or, there's a whole bunch of questions, and there's a lot of prejudices. There, as we look around us today, just things like racism, or the color of your skin, or the religion, will create a trigger in yourself as to how you behave.
Yeah, and I used to think that stress was also something I only had when I was really busy, or people could only be stressed when they were like, I don't know, working really hard or long hours, but you could also be stressed from sitting in your house if your mind isn't.
Yeah, there's different. There's good and bad stress, if you like. Is that the very nature of stress saves us from being knocked down by a bus? We sort of, oh, hang on, that's running a bit fast, I shall not run across the road or something.
Yeah.
We're in a constant sort of fluctuation of judging what's good or bad. It's only when things become in excess that it becomes a problem. So stress is our friend, but it depends on the context. Yeah. So if I come back to this PowerPoint again here, you have, if you sort of times those cells by a trillion, or 150 trillion, or whatever it is that you can see how the body behaves when it encounters a particular threat, whatever it is. Is that we have an emotional response, a structural response, and a biochemical response. So the emotional one is, oh, friend or foe, and then that will then feed that information into that biochemical response. The biochemical response will then cause the action. So that means, oh, run away or fight.
Yeah.
or smile or look angry or whatever it may be. Yeah. So this is an idea that was come up with by a doctor called Dr. Goodhart. And he calls this the triangle of health. And I've just sort of adapted his idea, this triangle. It's all interconnected. And what we mean by the emotional reaction, it's like, well, a lot of it we don't really think about, but it is part of our immune system. It's that first point of which we make these judgments, and it can be affected by so many different things. So the first of all is our five senses, you know, touch, taste, smell, sight. And I call it the field of perception, is that a lot of it is interpretation based on a series of rules that we've learnt along the way, cultural decisions. The five senses, as an example, you know, it's like, oh, does this taste good? Does it taste bad? And that can be based on whether you've had a good or a bad experience. The sight, quite a few people think about the senses as being external. It's like, oh, what I'm seeing is right. Well, actually, your senses are always affected by whether you're stressed or not, and particular, even colors affect the way we see things. And this is why in marketing, I think it's the coffee and chocolate. Almost all the time you see coffee and chocolate, the advertisers use red mugs or red cups.
Yeah, true.
To advertise. It's because it was found in a study that coffee and chocolate almost always taste better when they're in a red mug.
So weird.
And you can do it at home. It's a great experiment to do at home, really. You can have different coloured mugs, all the same shape, and you'll find that the red one, the coffee, it's the same coffee and the same chocolate, and it always tastes richer. And this is because the nature of colour affects how we judge things of what we see.
Yeah.
Even the ancient Egyptians understood this as well. Is this why they had red rooms and blue rooms in some of their healing centres?
Yeah.
Because if we're in a red room, we actually feel warmer than we do if we're in a blue room, and the temperature can be the same. And also in terms of our emotions, they're affected the same way. The same is true with hearing, is that our taste is directly affected by what we're hearing. So they did some tests on playing different kinds of music and tasting the same thing, and people would judge this. Oh yes, that's nicer, that's better, or whatever it was. And it was all the difference between whether you listen to heavy metal music or Mozart. Again, all these things can be changed. It's not necessarily it's always one way or the other, because it's very much unique to you and your own experiences.
Yeah. If you have a bad experience with something, it's probably. And
also then there's the stuff you've learned as a child, those inherited rules that come from your parents, or the main caregivers, versus the stuff that you've then learnt by yourself. And this is like, if you're born a zebra, then you're automatically afraid of a lion.
Yeah.
Yeah. And then through experience, when the lion's chasing you and you escaped, the zebra can sort of say, yeah, mum and dad are right. Lions are scary. That's and then there's the stuff that we underestimate. And that's the truly external stuff, which is whether you're in the daytime or in the nighttime. Is that we naturally are slightly more tense at night. We can't help it. Yeah. The temperature, depending on what culture you're brought up in, the temperature of the weather, we can either feel better or worse. If you don't happen to like, this cold, we are less prepared to be alert. If you imagine the watch guy in the castle again, is that you've got a watchman supposedly looking out for enemies, and he's too busy going, don't like it. Yeah, he's less alert than if he's feeling comfortable. The weather, some people love the summer and hate the winter. Other people are the reverse.
Yeah.
So how you feel directly affects, to a certain degree, how our immune system is working, in literally paying attention. The nature of fear is very dangerous. Fear stresses us out. So if we fear that something's going to get us, our immune system drops. If you're on your own, then your immune system directly is more stressed out. You can't help it. People can be comfortable being alone, but the statistics in terms of mortality rate is coming out that actually being isolated on your own actually has a direct effect in your mortality rates, stroke rates, these kinds of things.
That's not good news for me.
Well, me neither, you know.
Yeah.
So
but also the news, I see the news and economic.
Yeah, exactly. So the news, if you are being fed, you know, doom and gloom, which is what the news does tend to do a lot. Very rarely does news give you good news. It always gives you, you know, death rates and doom and it'll hit you and, you know, there's a burglar around there, or it's always negative stuff. So this is just simply a case of, there's at some point it's better to just get out in the sunshine and have a walk, interact with someone. And then economic status. This has come out from some of the work by a guy called Professor Robert Sapolsky, looking at that if you're rich in a poor country or poor in a rich country, it directly affects your immune system and how you're able to deal with stress.
Yeah.
So depending on whether you feel comfortable, you know, if you're going, it's inconvenient, but I'm okay, or you're going, how am I going to feed my kids?
Yeah, then you stress.
Absolutely, it gets to you, yeah. And we sort of all know this naturally. So the other part is the structure. It's literally, it's our skeleton. You know, our bones protect the brain. It's just the ribs from the lungs and the heart. All these things. The skeleton is part of our immune system. It's because it protects us from getting attacked. Yeah, you've got the organs which detox, particularly in the case of the lungs and the liver, and of course the kidneys. You've got the skin. The skin is impermeable. So most of the time, viruses literally cannot get in on the skin. Yeah, unless of course the skin's broken. But the skin itself is your first line of defense, and is covered with bacteria, which protects you from other sources. And that's the advantage. We forget that it's something like 99% of all bacteria are actually our friends. Yeah. We've got fat that again protects us from lots of toxins. Then the muscles and the fascia and the nerves, these kind of things, quite literally, they help us run away from a threat. Yeah. Someone coughs in your direction, literally it protects us. And then of course, then you have the health of the arteries and the veins and the fluids inside them that help transport nutrients and get rid of waste. If they're not healthy, then obviously you've got less ability to protect yourself.
Because you also hear a lot about it in the news that when people are obese, that they have less surviving chance, or that they're more likely to get it, or that they're more likely to be really sick of the virus.
Yes, I mean this is sort of normal. This applies to any health issue. That's a fine example in the sense that if one part of that system, let's say your structure, isn't healthy, and this is not a judgment of whether being fat or skinny is healthy or not healthy, because there's plenty of people who are fat and healthy, and there are plenty of people that are skinny who are not healthy. So just based on your size isn't really a good marker for health.
No.
However, we sort of know in ourselves, we can see someone who is naturally big, and you can go, he or she looks like a healthy fat person. Whereas when we see someone who is like,
I wouldn't say fat.
It doesn't matter, cuddly or whatever you want to say, is that we sort of know. It's like we can look at someone and that person, regardless of their size, we can just go, they don't look well. And it's not to do, and they could be fat and don't look well, or they could be skinny and don't look well. Yeah. So the nature of, life would be so weird if we were all clones and we're all the same height, the same size and shape as each other. And that's not how human beings are. And so it's that, yes, there are extremes. There are people that, they could do with losing a few pounds. There are also people that could do with gaining a few pounds. because fat is also our friend in terms of how we get rid of toxins. That's what fat is for. It's really good stuff. So if I go back to the third part, which is the biochemical bit, we have what goes in to our system, which is the food we eat, proteins, fats, carbohydrates, minerals, water, fiber, and of course oxygen. And then we get rid of those, all that stuff, which is the waste product. And that comes out of through our feces and urine and out of the lungs. And the main sources of that, or rather the way that the body deals with this, is that in essence the feces, it contains the fat-soluble toxins, urine, the water-soluble toxins, and then the lungs, any gaseous toxins.
Yeah.
And then the backup system, the secondary part, is the mucus and the skin. So our tears and our saliva, the mucuses within our system. Yeah. So when people have, a skin problem, it's usually a good indicator that something in the primary section is not working at 100%. It's not at optimum. Yeah. Yeah,
that's what I had.
Yeah.
I had acne and it's a liver problem.
Yeah, and that is the way it works. Is that it is. And what is worth remembering is that the majority of the toxins that our system is producing is by breaking down all that input, all that food and the stuff we take in, is that the cellular process, that's, the change of oxygen and carbon dioxide and magnesium, calcium, and lots of other things, that's called metabolic waste, the waste process of what goes on in the cell. And that's 90% of the toxins that our body produces. That's what our body has to deal with.
Yeah.
And so it's really only 10% that the body has to deal with that is the outside stuff. In other words, chemicals in our food, breathing in toxic gases or radiation or pathogens and other things. And so again, as a marker, if we become super sensitive to a metal or a chemical or radiation, it's a good indicator that something in the main way in which our system detoxifies is not working at optimum.
Yeah.
Okay. So the basics of how the immune system work, and this idea is sort of about 100 years old now, and there's still doctors that still they talk about this is the way it works, and it's like, well, it's a good model at basics, but there is a little more to it. But in basic principles, and we sort of all heard of these white blood cells and red blood cells, which protect us from nasties. Yeah. And this is called the innate system. And the innate system is sort of on automatic. It's the infantry and the cattle that just there's lots of them and they go, charge and attack. Yeah.
Okay.
And it's non-specific. Okay.
Yeah.
So that means what goes on is when our body encounters a bacteria that's judged to be nasty, white blood cells come along and destroy it. If the system and the white blood cells can't defeat that attacker, then it's then passed on to the antibodies, or rather the adaptive system, which then produces antibodies which are specific to a particular virus or bacteria. So it comes along and the antibodies attack the virus and destroys it that way. Yeah. There is actually, it was found I think it's about 50 years ago. It takes an awful long while for doctors to get updated half the time. Is that we find there's actually this middle part of it, another completely separate system called the Interferon System. Mm-hmm. And it's, as the name suggests, it interferes with attacking viruses. And it's because, as with many viruses, they have their own armor shielding. Yeah. And in the case of a good portion of viruses, is that armor shielding is like a greasy layer. And this is why using soap and water is more effective than just using pure alcohol, is because actually things that destroy grease, like, soap or fairy liquid or whatever it may be are far more effective against viruses than something like alcohol, because if you actually put oil on alcohol, it'll float, it won't actually dissipate.
Okay.
So this is exactly what happens in the case of the interferon system. Is what you have is you encounter a virus that has this shielding around it. So something called cytokines produced by the interferon system attack the grease, and so it gets rid of that shield, so that then the white blood cells can then attack the virus and destroy it that way.
Yeah.
And then if that doesn't work, then it then feeds to the adaptive system and goes to the antibodies. Yeah. And the reason, one of the main reasons that this goes on is because the adaptive system takes a lot more energy to do. The body would prefer to do it automatically and deal with things automatically. It's like, yeah, quick, let's get it over and done with. Because the longer something goes on, the more energy the body is using. And the antibodies are sort of, they can be, if there's too many of them, they can be a bit like, you know, the troll in Lord of the Rings, is that, you know, it's a big weapon. It's really good at swatting, you know, bad guys. But if you're anywhere near it, you could also get damaged yourself.
Yeah.
Yeah. So there's something else worth mentioning, is that this is what is going on in the body as a whole, but there is a separate system that is allocated just for the brain and the spinal cord. Yeah. And this is called the neural system. So
the brain and the gut are...
Yeah, so it was seen as it was often believed that the brain is completely separate in terms of its immune response, which it is because the brain is separate. It needs to be the most protected thing, so it has its own separate immune system, if you like.
Okay.
And then it was discovered that there's also, you know, we've sort of now heard of it now, but in the sort of 1930s, they sort of discovered that not all bacteria are bad. Mm-hmm. Is that actually bacteria are our friends. Now, because of the success of antibiotics in the Second World War, is that people then didn't hear about probiotics for a very long time, until probably in the last sort of 10, 20 years. Because, you know, antibiotics, oh, they kill bacteria. And of course, in some areas, people still believe bacteria are deadly, they're all going to get you. It's actually, well, the majority are actually our friends. It's actually 0.05% of bacteria are actually dangerous for us.
Yeah.
Yeah. And so most of us probably have heard of this idea of friendly bacteria in our gut. Yeah. And then it turns out that there was a communication network between the gut and the brain. And it turns out that actually we're now nicknaming it the second brain, is because there are 9 times more neurons giving the brain instructions than the brain giving the gut instructions. And we sort of have it in our own language. We sort of say, you know, oh, I have this gut feeling.
Yeah.
Yeah. We sort of go, oh, yeah, I'm not sure about that. And this is the instinct bit. This is sort of the zebra going, is there a lion around? Yeah. It isn't necessarily always right, because we're talking about instinct, and that's not the same as intuition. Yeah. So it's not got much wisdom, but it is a very useful initial response. Yeah. So this was then sort of updated, because it turns out there's actually more to it, because it's not just about bacteria. It turns out there's quite a lot more going on. Yeah. So it was previously known as the gut-brain axis, but the update now is we now are calling it the microbiome gut-brain cerebral spinal fluid axis, which is a huge mouthful. Yeah. And this is because it was then noted that the microbiome, which is our body, is actually completely filled with funguses, viruses, and bacteria. And they're on our side. They're not our enemies. They are what make us think. They're what make us walk. They are they produce vitamins in many cases for our system. They live symbiotically with us. And it's not really surprising. You know, we sort of know that we all work together, really. It's just that.
But is it then that the 90% friendly fungi, viruses, and bacteria, they kind of communicate or with the neural system? Or how should I interpret?
Well, this is it. It's The answer to most of these questions is we don't really know enough yet, because it's still a relatively new idea. It's like anything. It's like the best way of looking at is how human beings interact with each other. We're all different. We all have our own skills. We all have our own products. We all do different jobs, and yet it all works. And some of us interact with different types, and others sort of stay in one place. The way a country is run, if you like a bit, there's a sort of a hierarchical structure. You have the governors, and then you have sort of the councils, and then you have the workers, and then the healthcare professionals. It's very similar. Basically, it is the same in the human body. That we are all part of the one thing. Belgium is Belgium.
Yeah.
But then you say, well, how does Belgium work?
Oh yeah.
I don't know. Well, yeah, exactly. We don't really know, but it does, you know. And the same with the UK. We might not think it is. There might be some parties that go, it's not working very well. But actually, it is working.
Yeah.
And there are good days and bad days, the same as we all have good days and bad days.
Yeah, okay.
So, but it's all interconnected.
Yeah.
Yeah, one way or another. So, if we go back to the original slide, so here we have the sort of 5 parts of the immune system. Yeah. Now, as I said before, this neural system, which is sort of the brain and the cerebral spinal fluid, what goes down the spinal cord, was believed to be completely separate, because what you don't want is to have a fever, but it's actually directly affecting the brain. Yeah. So it's kept completely separate. And so you have this sort of, the immune system is sort of the body, and then you have our separate immune system and the neural system and this gut-brain axis. But what was then found is that sometimes you can get a virus in the brain. Yeah.
Yeah.
Now, what happens then is that when it comes along,
at first.
Yeah.
Yeah.
Why is it not? So the virus could come in like that. Then what actually happens is both the innate system and the adaptive system will create special tiny cells to cross this blood-brain barrier, which is normally means that nothing can get in and past, and will then help destroy the virus that's attacking the brain. So the whole of the immune system is always working based on priorities and what's important. So if needed, the human system is really, really clever. And this is worth remembering.
Yeah.
Is that actually we often underestimate
what the body can do.
Yeah, is that we often say, oh, we can't do this and we can't do that. So, well, if you keep telling yourself that, then sure, you'll be right.
But that's also why we should really take care of our...
Absolutely. And this is the main difference between... this is the main difference between, if you like, mainstream medicine, which is pretty much geared to dealing with the symptoms once the system has already had a problem. And they do a really great job. In, you know, if you've got a broken leg, you know, then, you know, you need to go and see a doctor. You know, you need to have it put in plastic cast. They do a fantastic job at acute problems. In terms of my job is keeping the body at its optimum, which means that I'm far less likely to get viruses and bacteria. And it's the other argument that sometimes we actually need, much like a computer, we actually need an upgrade on a regular basis. The very nature of getting sort of like a cold or a flu on a regular basis is that our immune system is continually updated, so it gives us a much better chance of defeating ones that come along later. Getting a cold is a good sign that your body is updating. If you think of it as being an upgrade to your immune system, it's a much better way of thinking about it rather than simply thinking, oh, I don't want to ever get a cold. It's like, well, you know, some diseases absolutely don't want to get.
Yeah.
But sometimes you do actually, it's worth being sort of almost tested. The system needs to be tested to be continuously up to date.
Yeah.
Okay.
Very interesting.
Okay. I hope that was useful. I hope it makes any sense. I hope it makes a lot of sense, actually. So.
Yeah. I got it all. I really, it's really interesting to have to also. It's also reassuring, you know.